Hi there, everyone. Welcome. Glad you are here. This is Miss Page, and in this lesson, we are going to learn how to find trigonometric values of angles that are coterminal to our unit circle angles. So in a previous lesson about coterminal angles, we learned how to start with an angle. This one here is shown in radian measure. And find an angle in the first positive revolution, or what we just call the first revolution usually, which would be from 0 to 2 pi for radians. And that also is the values that we see in our unit circle. So we learned that what we would do is multiple ways, but one way is to look at this as a mixed number, realize, okay, this is bigger than 2, therefore I'm going to have to subtract a revolution of 2 pi. And then I evaluate after that subtraction. So this is 3 minus 2, which is 1, and the 1 3/4 is what we have here. And this is now between 0 and 2 pi, so that satisfies the conditions of being in the first revolution. And then in the improper fraction form, our unit circle form, we have 7 pi/4 for that angle. We are simply adding this step to the problems or lesson in which we found the trig values of directly of our unit circle angles. So now we just have to find that angle that's coterminal to the given angle that is in our unit circle, and then it's actually much like or the same as what we were doing in that previous lesson. All right, so that's what this is describing. So we need an angle that's coterminal in our first revolution between 0 and 2 pi. We're exclusively going to be working with radians this time. And then we use our knowledge of the unit circle and our trigonometric identities to find whatever value we need. And then that will be the sine, cosine, tangent, cotangent, secant, cosecant of the original angle that was coterminal to this unit circle angle. The identities that we're going to need, similar to or the same as our lesson on finding the trig values of unit circle angles, are our quotient identities for tangent and cotangent, and the reciprocal identities specifically for cosecant and secant. We don't really need to use the others for these problems, but they're there for reference so we can start becoming more comfortable with them as reciprocal identities as well. All right, so let's take a look at this problem. Again, we are using our knowledge of the unit circle, angles, and the values of the points which represent x as cosine and y as sine of our angles, and identities when necessary to find each exact value. Here we're looking to find the sine of 8 pi thirds. Now for sine, we don't need an identity because the sine and the cosine values are in or part of our unit circle. This will be a y value of whatever point is coterminal with this 8 pi thirds in our unit circle. So that's what we're going to do first. We want to find that coterminal angle. So our 8 pi thirds, as 8 thirds is a mixed number, would be 2 2/3 times pi. So subtracting off a full revolution, always full revolution, so multiples of 2 pi. In this case, just 2 pi, that gives me 2 minus 2 is 0, so I have this 2/3 here, so I have 2/3 pi, which is 2 pi thirds as a unit circle angle. So what this is telling me is that the sine of my 8 pi thirds and the sine of my 2 pi thirds will be the same value. So that's what I need next. What is the sine of 2 pi thirds radians? So here is where it is helpful to know, okay, well, that is going to have a reference angle of 60 degrees or pi thirds radians. It's going to be 2 pi thirds is going to be in the second quadrant. Sine, which is y in the second quadrant, will be positive, and so our sine value will be a positive value, and the same as the value then for the sine of pi thirds, or 60 degrees. And that would give us then a sine. Remember, sine of 30 degrees or pi 6 radians is our 1/2, which means sine here of our 2 pi thirds, which has a reference of that 60 or pi thirds radians, would have to be the square root of 3 over 2. So then that tells us that our original expression here, our sine of 8 pi thirds, is also this square root of 3 over 2. Like so. All right, let's take a look at another problem. All right, so here we are going to find the cosine of negative 11 pi fourths radians. Again, we're not going to need our trigonometric identities because cosine is part of our unit circle. It's our x-coordinate. We just need to figure out what angle in our unit circle is coterminal with a negative 11 pi fourths radian. So we do that first. So our coterminal angle is looking at our negative 11 pi fourths. So if I look at this as this negative 11 fourths is a mixed number, that would be negative 2 and 3/4 pi. Now you could do this in one or two steps. One thing I realize is that adding 2 pi isn't quite going to be enough because I'm still going to be left with this negative 3/4 pi. And unit circle angles, remember, are all positive. They are in the first positive revolution from 0 to 2 pi. So I could add 2 pi, which would give me that negative 3 pi fourths. And then I could add another 2 pi, or my option would be to take this negative 2 and 3/4 pi and add 2 full revolutions of 4 pi and figure out what that is in one step. Either way works. It just depends sort of on how you see it at the beginning and what you're most comfortable with. So here I have 4 minus 2, which would be 2. And then that 2 that's left over, I also have to subtract a 3/4 from. And 2 minus 3/4 would be 1 and 1/4 pi. And as an improper fraction, this would be 5/4. So this becomes 5 pi fourths. So what this means is that the cosine of my negative 11 pi fourths is the same as the cosine of 5 pi fourths in my unit circle. So now I'm thinking about, well, what is the cosine of 5 pi fourths? Well, anything that has a denominator of 4 is going to be coterminal with pi fourths, or not coterminal, is going to have a reference angle of pi fourths in the first quadrant. And that's our 45 degrees, in which we have sine and cosine are both root 2 over 2. So what we need to figure out is what quadrant this angle is in, so we know, is cosine going to be positive or negative. 5 pi fourths is in the third quadrant, in which x is negative, so that means this would be a negative square root of 2 over 2. That also means then that the cosine of our original angle is also this negative root 2 over 2. Like so. All right, there is a practice problem next. So when I change the screen, you should pause your video, give the practice problem a try, and then I'll pull up the answer and we will be able to compare. Here you go. Pause the video. All right, so let's see how you did. So in our first step, our coterminal angle for negative 11 pi 6, looking at it, here's the progression, is pi 6 radians. And that means that the sine of our negative 11 pi 6 is the same as sine of pi 6, which is our 30-degree angle. So that is 1/2, which means the sine of negative 11 pi 6 is also 1/2. Let's try this practice problem. So once again, pause the video. All right, let's take a look at the result here for the cosine of 5 pi radians. So here, 5 pi radians, here it's showing subtracting 2 pi twice, because we didn't, with subtracting 1 pi, it wouldn't be enough to get us into that first revolution between 0 and 2 pi. We could have also combined these and subtracted 4 pi, which would also given us our pi. So now, these are coterminal, 5 pi and pi. We are now looking at the cosine of pi in our unit circle, which is negative 1. And that then means that the cosine of 5 pi will also have to be negative 1. All right, we're going to go back to doing some examples now. Let's take a look at this one. So now we're moving away from sine and cosine, and here we're looking at finding the secant of 7 pi halves radians. So here we are going to have to use a trigonometric identity, but I won't do that yet. What I'm going to do first is find my coterminal angle in my first revolution within the unit circle 0 to 2 pi. It's for 7 pi halves. So that coterminal angle for 7 pi halves radians So 7/2 is 3.5. So that's 3.5 pi. Subtracting 2 pi, that gives me 1.5 pi. And 1.5 pi would be 3 pi over 2. So this is telling me that the secant of 7 pi halves will be the same as the secant of 3 pi halves. So now I have to use a trig identity because secant's not part of the information in our unit circle. So now we have to know that secant is the reciprocal of cosine. So this will be equal to 1 over the cosine of 3 pi halves radians. Now we need to know, well, what is the cosine of 3 pi halves radians? So 3 pi halves radians is one of our quadrantal angles, meaning that its terminal side is on either part of the x-axis or the y-axis. And the values there are always going to be 1, -1, or 0. So we just got to make sure we get the right situation. The cosine of 3 pi halves, which would be the x-coordinate of this point, would be 0. So that then gives us a ratio of 1 over 0. And as we discussed with our number sense, this would be undefined because there is nothing times 0 that equals 1. So this would be undefined. And that then tells us that the secant of 7 pi halves radians is also undefined. Like so. All right, let's see what's next. So here we're looking at finding the cotangent of -7 pi 6 radians. All right, so again, we'll need to use an identity here because cotangent values are not part of our unit circle information. But before we do that, we need to know what angle in our unit circle is coterminal with this -7 pi 6 radians. So our coterminal angle for -7 pi 6. So as a mixed number, that would be -1 1/6 pi. So I'm going to add a full revolution of 2 pi radians to that. And so the math here would be 2 minus 1, which would be 1. And then from that 1, I also have to subtract the 1/6. So 1 minus 1/6 would leave me with 5/6. So I have 5/6 times pi, which would be 5 pi over 6. So this is telling me that the cotangent of -7 pi 6 radians will be the same value as the cotangent of 5 pi 6 radians. So that's where I go next, looking at the cotangent of 5 pi 6 radians. So now I need to use one of my quotient identities. And remember that cotangent starts with a c. So in the ratio, cosine, which starts with a c, is what we will find. So this is the cosine of 5 pi 6 radians over the sine of 5 pi 6 radians. So now I need both of those values. So 5 pi 6 is in my second quadrant. It is coterminal with pi 6 radians, which also has a denominator of 6, and that's our 30-degree angle. 30 degrees has a sine value, remember, of 1/2. In the second quadrant, y, which is sine, is positive. So this will be still a positive 1/2, just like it is for pi 6 radians, or 30 degrees. But cosine in the second quadrant is x. Well, cosine is x, and in the second quadrant, x is negative. And so the cosine of 5 pi 6 radians will be negative. And what goes with a 1/2, remember, is always a √3 over 2. So we get a negative √3 over 2. So now we use a little bit of basic math here. This would be our -3 pi halves divided by the 1/2. And so this becomes times the reciprocal. So that's times 2 over 1, or 2. And then our 2's reduce to 1. And this becomes the negative square root of 3. So that is telling us that this cotangent of our original angle, -7 pi 6, will also have a value of negative square root of 3. There we go. All right, there is a practice problem coming up next, so get ready to pause your video. Here is your practice problem. All right, let's take a look at the value for our cosecant of 5 pi fourths. So here we go. That's 15 pi fourths, sorry. It's cosecant of 15 pi fourths. So that would be 3 3/4 minus 2 pi gives us 1 3/4 pi, which is 7 pi fourths. So now we're looking at the cosecant of 7 pi fourths. Reciprocal identity says that would be equal to 1 over the sine of 7 pi fourths. The sine of 7 pi fourths, which is in our fourth quadrant where y is negative, would be negative root 2 over 2. So we get 1 over that. That's 1 times the reciprocal of that, which becomes negative 2 over root 2. That becomes negative 2 root 2 over 2 when rationalized, and the 2's reduce, remember, dividing 2 divided by 2 is 1, or reducing by 2 to give us negative square root of 2. All right, let's try another one. Here, pause your video. All right, let's take a look at the result here. So here, negative 10 pi thirds, negative 3 1/3 pi. We have to either add 2 pi twice to get to a positive angle in the first revolution, or we can add 4 pi. Either way, we're looking at 2 pi thirds as our coterminal angle. Tangent of 2 pi thirds, we have to use the quotient identity. Remember that cotangent, which starts with the C, then has cosine in the top, which means that tangent will start with a sine in the numerator's position. So we get this ratio. Then the sine of 2 pi thirds radians, which is in the second quadrant, would be positive. In this case, root 3 over 2, because it has that reference of pi thirds radians. And cosine of 2 pi thirds would be negative, because x in the second quadrant is negative. We have a negative 1/2. Then multiplying by the reciprocal of the negative 1/2, we end up with negative square root of 3. All right, there is one more practice problem for you to give a try. Pause your video. All right, let's take a look at this one. So here, cotangent of 13 pi halves. We are looking at, that is 6½ as a mixed number. Here it shows just subtracting 6 pi, which is 3 revolutions of 2 pi radians. Again, you could do it one at a time, or here it's shown all together. 6½ minus 6 would give us 1/2, which is pi halves. So the cotangent of pi halves radians would become the cosine of pi halves over the sine of pi halves. Cosine of pi halves, which is your 90-degree angle, which is x at that point, is 0. And 0 divided by 1 would be 0, because remember, 1 times 0 is 0. That means our cotangent of 13 pi halves will also be 0. All right, that's all we have for this lesson. And you may start your assignment. Have a good day.